Great day, learners. It's me again, Miss Bethel. So let's continue our discussion about statistical experiments, talking about experimental designs. So the next experimental design that we're going to discuss is about randomized complete block design or RCBD. So readings coming from Gomez and Gomez, page 229, and Steele and Torrey, pages 195 to 215. So when we talk about randomized complete block design, quote unquote, complete block, we are actually referring to a unit that contains every experiment. Thereby saying that in RCBD, we include blocking, okay, as one of the sources of variation. So RCBD is actually one of the most widely used designs in agricultural research, because in agricultural research, most of this, we are conducting this at field level. We would consider variation and heterogeneity of the area. So this is appropriate or best suited for field experiments where the number of treatments is not large enough, and the experimental area has predictable productivity gradient, quote unquote gradient. So we try to consider the gradient, fertilizer gradient, or occurrence of pests, or source of light, source of water. It depends on our goals and on the treatments that we're going to impose. And to use RCBD or randomized complete block design, we must be able to group EUs or experimental units to blocks. And blocks must be large enough to contain all the treatments. So, kunwari, you have 16 treatments, meaning each block should contain all the necessary 16 treatments. Then what is its distinguishing feature? So the presence of blocks of equal size, each of which contains all the treatments. Again po, equal sizes yung mga blocks, tapos lahat ng blocks or each block, dapat included doon lahat ng treatments na ating i-impose sa ating experimentation or sa ating study. So actually, RCBD is a two-way classification. Each observation is classified according to two set of criteria. First is the treatment effect and the block effect. Unlike po sa ating CRD, wherein ang ating lang kinukonsider ay ang ating treatment effect, wala pong blocking. RCBD po, distinguishing feature, may block, iisang block, lahat ng treatments andun. So what is the model? So Xij, sorry, na-double yung equal, is equal to the population, overall population mean plus TI plus the BJ or the blocking, no? And the EIJ. Same as the CRD, pero ano ba yung additional? Blocking lang po. Or the effect of the J block. Or overall population mean plus the effect of the I treatment plus the effect of the J block plus the IJ or the treatment means. Okay? Now, we tried also to consider this one. Okay? Consider what I've mentioned in our last learning video about the NID. Then for blocking technique naman, the purpose of this is to reduce experimental error. Again po, in any other experimentation, sa lahat po, we are trying to minimize or reduce the experimental error. So for RCBD po, how to reduce experimental error? We eliminate the contribution of known sources of variation among the EUs or experimental units. Or we could actually group the experimental units into blocks to minimize the variability within each block and maximize the variability among the blocks. Again po, i-minimize ang variability or difference sa loob ng iisang block, pero i-maximize po natin yung variability among the blocks. And then only the variation within a block becomes part of the experimental unit. So blocking is most effective when the experimental area has a predictable pattern of variability or may gradient po siya. So what are the two important decisions that we must consider? First one is the selection of the source of variability. The second one is the selection of block shape and the orientation, which is the ideal source of variation should be large and highly predictable. So for example, soil heterogeneity, so iba-iba po yung fertilizer gradient, or direction of insect migration, or it could be kung gaano ka-steep or slope yung field natin. So, there are actually 3 general blocking criteria. First po yung time, second yung space, pangatlo po yung tao or the people. So, guidelines on block shape and orientation. So, here's the first one. When the gradient is unidirectional, well, isa lang po yung direction niya, use long and narrow blocks. Kung iisa lang po yung direction. So, orient blocks perpendicular to the gradient direction. So, kung pa dito po yung gradient natin, dapat yung blocks po natin ay pa ganito. Block 1, block 2, block 3, block 4. Para po, within each block, pare-pareha po sila. Kung kunwari, ito yung pinaka-least, yung gradient ng nutrients, ito yung pinaka-high, pinakamataas yung gradient ng nutrients. At least po, yung buong block na ito, pareho po sila affected na maliit yung gradient ng nutrients. Tapos, itong block na ito, pareho po lahat ng treatments na medyo mataas yung gradient ng nutrients. Kasi po, pagka hindi po perpendicular yung ating gradient, bali sa iisang block, unfair po. Kasi kunwari, parallel yung ating blocking, so ito yung gradient, ito yung ating blocking, ang mangyayari po, iba-iba po yung marireceive na nutrient ng ating treatments sa loob lamang ng isang block. I hope you are with me in this context. Then, second one is, when bidirectional naman po, dalawa yung directions ng ating gradient, with one gradient, much stronger than the other, ignore the weaker gradient and follow the guideline number 1. Ano ba yung guideline ng ating number 1? Again po, perpendicular to the direction of the gradient. The third one, when bidirectional with both gradients equally strong and perpendicular to each other, either we use blocks that are square as possible para po lahat ng treatments ma-ensure po natin na same lang po yung nare-receive nila, kunwari nutrient po, or use long and narrow blocks with their length perpendicular to the direction of one gradient and follow guideline number 1, and use of covariant technique to take care of the other gradient. Or LSD naman po ating gamitin, or wag po tayo mag-shortcut ng LSD, baka po sabing least significant difference. Latin square na lang po. LS design po, okay? Latin square design with two-way blockings, one for each gradient. And the fourth one is, when the pattern of variability is not predictable, blocks should be as square as possible. For the randomization and layout naman ng ating Rcbd, kasi po sa ating CRD, masyadong madali yung ating layouting. Hindi tayo ganun ka-stricto. Pero sa Rcbd po, dapat mag-follow po tayo nito. First one, divide the experimental units into R blocks. Ilan po ba yung ating blocks? So, R po natin, yun po yung ating number of replication. We should follow proper blocking technique. Second, subdivide each block into treatments or T experimental units, where T is the number of treatments. So, ilan po ba yung ating treatments? Kunwari, 4 po. Dapat sa isang block, merong 4 na treatment. Yung pangalawang block, o yung replication na pangalawa, yun po yun, dapat may 4 din na treatment. Yung pangatlo, kung hanggang 3 lang po yung ating treatment, or rather yung ating replication, dapat yung pangatlo, meron din pong 4 na treatment. Third one, randomly allocate the treatments to each block, making sure that each EU in a block will have equal chance of receiving any treatment. Yun po yung sinasabi ko kanina, kung ilan po yung treatment, dapat present po yun sa tig-iisang block. Okay, dapat sa lahat po ng block, same po yung number of treatments. So this is our example. Kunwari, ito yung ating gradient. Kunwari, dito yung pinakamaliit na nutrient. Kunwari, this is the whole land. Tapos, gumawa ka ng soil analysis. Tapos, nalaman mo itong part na ito ay medyo maliit yung nutrients. Ito, okay lang. Ito, pinakamalaking nutrients kasi po, katabi niya ay compost pit, kunwari. So, yung blocking po natin, perpendicular. Dito po pupunta yung gradient. Itong ating pong block po ay perpendicular sa ating gradient. Hindi po parallel. Bakit po siya kailangan na perpendicular? Kasi itong block na ito, kunwari block 1, 25% lang yung soil inherent fertility. Ito naman po, 50%. Ito, 75%. Ito, 100%. Tapos, may iba-iba kang treatment. So, yung treatment mo ay 5. So, bali po, ito pong block 1 kasi sure ka na kahit iba-iba yung treatment, lahat ng treatments na ito ay meron lamang 25% na soil fertility. So, wala pong bias doon. Kasi pareho naman ang lahat ng treatments na ito na naka-receive ng 25. Yung block 2 naman, 50% ang soil inherent fertility. So, okay lang kasi affected lahat ng treatment. Ito, 75%. Okay lang din kasi affected lahat ng treatment. The same is true with the last block or block 4. So, 100% yung soil inherent fertility. So, lahat po ng treatment ay apektado. Kasi po, pagka ipoposisyon natin na parallel, ito kunwari, block 1 to lahat. So, bali yung mangyayari, kunwari si A dito, si C, si B, si D, si E. Bali, bias na po siya kasi po yung E po, medyo malaki na yung soil inherent fertility niya compared dito sa naunang A. Kaya po dapat yung ating blocking technique is perpendicular to our gradient. I hope po na naintindihan natin yung ating explanation. So how about CRD versus RCBD? In CRD po, randomization is done without any restriction. Okay lang, i-assign mo lang siya kahit saan. Basta ma-assign mo lahat ng treatments mo doon sa experimental units. Pero sa RCBD naman, there is one restriction in randomization. You must consider that all treatments should appear in each block. At that in each block po, dapat yung ating blocking technique po, perpendicular siya sa ating gradient. Pero i-consider din po natin yung ibang criteria kasi sinasabi dito, pagka unidirectional po, pero pagka bidirectional naman, so meron din pong ibang criterion. But again, it would always boil down to the idea na bumalik pa din tayo dun sa orient blocks perpendicular to the direction of the gradient. Okay, so now how about the advantages and disadvantages of RCBD? So, RCBD is more precise than CRD if blocking is effective. Pero kung mali po yung ating blocking, bias na po yun automatically. Kaya po, importante na alam natin kung paano tayo mag-blocking in RCBD because pohon-pohon, kung mag-thesis mo, ang mahitabo, kamo ipa-block sa inyong professor. So, basin makasabaan tanong if di takabilog blocking, if di takabilog randomization using RCBD. And simple to understand versus more complex design niya kasi meron po tayong orthogonal, meron pa po tayong ibang experimental design. Okay? And any number of treatments and reps is allowed with RCBD. And disadvantages, if blocking is ineffective, precision is lost compared to CRD. So talagang mali na po lahat kung mali po yung ating blocking, yung ating plotting technique. Second one, homogeneity within block is often reduced as treatment number increases or as block size increases. So this is not a disadvantage compared to CRT. So neglect na lang po the letter B here. So the higher the error DF, the better is your estimate of the error. So ito na po yung ating ANOVA for RCBD. Kung sa CRD po, TET lang po, treatment error at saka total. RTET naman po sa ating RCBD. Replication, treatment error at saka total. So para po makuha yung ating DF, RDF, replication DF, treatment DF, error DF at saka total DF, to compute for the replication, we simply subtract 1 from the replication for treatment. So it's T minus 1 or treatment minus 1. For the total, it's N or the total experimental units minus 1. For the error naman, it's total DF minus the replication DF and the treatment DF. For the SS, our RSS, we have the TRSS, the ESS, and the total SS. We also have the mean square of the replication, mean square of the treatment, and mean square of the error. Then to compute for the F of the replication and the F of the treatment, we have MSR over MSC and MSTR over the MSE. So to compute for our CF, still the same with how we compute with the CF in the CRD. It's the square of the summation of X over the total number of experimental units, that's its CF. For the RSS, we simply square each replication and then get the sum of it and divide it with the treatment minus the correction factor. For the total SS, it's the sum of squares minus the CF. TRSS naman is squaring each value of the treatment and then adding them all divided with the replication minus the correction factor. For the error SS, it's simply total SS minus the replication SS minus the treatment SS. To compute for our MSR, we simply divide the replication SS over the replication DF. For the MSDR, divide the treatment SS to the treatment DF. And for the MSE, we simply divide the error SS to the error DF. So to compute for our F for the treatment, we have the MSTR over the MSE, and the F computed for the replication, we have MSR over the MSE. So let's have for the CV naman, square root of MSE over the mean times 100. For the standard error, we have the MSE over R, and the SD, we have square root of 2 MSE over the. For our decisions naman, it's just the same with our decisions earlier with CRD, that it's highly significant if the F computed is greater than the F tab at 1%. It's significant when the F computed is greater than the F tab at 5% but less than the value of the F tab at 1%. Non-significant when the F computed is less than the F tab value at 5% level of significance. So let's have this sample problem. So still using not the same problem earlier, but of course we have the blocking. So this is our block 1, block 2, block 3, and block 4. So this is our total of the treatment. So adding 47 to 51, it's 212. Adding 50 to 57, it's 228. Adding 57 to 57 again, it's 236. And after adding 54 up to 59, it's 252. For our blocks naman, this is our blocks. So we need to add 47 up to 54 to come up with 208. 52 to 65 to come up with 224. 62 to 74 to come up with 272. And adding 51 to 59 to come up with 224. If we're going to add 202, 224, rather 208, 224, 272 plus 224, it would give us a total of 928. This is our grand total. If we're going to add this one, it's again 128. To get the mean, we divide this value by 4 to get 53. 228 divided by 4 to get 57. 236 divided by 4 to get 59. And 252 divided by 4 to get 63. So dividing 9 to 8 to 16, the answer is 58. To compute for the correction factor, we just square the grand total or square of the summation. So we have 928 squared over 4 times 4 because this is our replication and treatment. So 16, so 53,824. For the total SS, we simply get the sum of squares minus the CF. So it's just squaring all of these values individually. So 54,678 minus 53,824. The answer is 854. Then to get the replication SS, we simply get the square of each replication or each block, okay, and add all of them. So 208 square plus 224 square plus 272 square plus 224 square divided by our treatment, which is 4, minus the correction factor to get 576. For the treatment SS, we simply square each value of treatment 1, square treatment 2, which is 228, 236 square, 252 square, divided by replication, which is 4, 1, 2, 3, 4, minus the correction factor, the answer is 208. For the error SS, we simply subtract the replication SS and the TRSS from the total SS to come up with our answer. So now we need to plug in all of those values in our ANOVA table. So again, replication is 3. 4 minus 1. Treatment is 4 minus 1. It's 3. Then we have our error DF, which is 9, and treatment DF. Rather, total DF, which is 15. So we get these values of the SS from our previous computation. 526, 208, 854, and 70. So to get the MSE of the R, ano ba yun? To get the MSR, we simply divide 526 over 3 or the RSS over the RDF to come up with 92. 208 divided by 3 is 69.33. That is dividing the TRSS to the TRDF. Then to get the MSE, we divide 70 over 9 or the ESS over the EDF. To get the CV, square root of MSE times mean. So 7.78 square root of that divided by 58, the answer is times 100, the answer is 4.81. To get the FC, again, how to compute for it? It's 192 divided by 7.78 to come up with 24.68, and 69.33 divided by MSE, which is 7.78, to come up with 8.91. How do we get this value again? So gamitin lang po natin ang ating table. So 3 po yung ating replication, tapos 9. Kaya 3.86 at saka 6.99. Swerte po tayo kasi 3 din po yung ating treatment. Kaya 3 lang din po dito na value at saka 9. Pero kunwari po ang ating treatment ay 6, kaya po titignan natin ay 6 at saka 9. Pero parehas man sila duha, 3 ang ilahang MS, ang iyahang, replication o treatment parehas 3. So, we use 3 here as our DF, and diri ang atong error DF. So, that's it. Tapos na po tayo sa RCBD. I hope that's very useful for you, for your part. Please study well. God bless us all. Thank you, and have a great day ahead of you. This is Miss Bethel saying, please study well. Thank you.